Hi, my name is Behnaz Arzani, and today I'm going to be talking about revisiting data center management, moving towards self-managed data center networks. If we look at how our networks have evolved over the years, we've moved from the ARPANET in December 1969, which was just a collection of nodes, to the bigger internet that had over 1 million nodes, and today we operate data centers that are almost just as big. And the problem we've run into is if we look at one of these data centers, they have a lot of moving pieces and components. We have virtualization to allow multiple VMs to be running on a single server. We have disaggregation, specifically today in the form of storage clusters that form the storage for these VMs. We have many logical components, load balancers and virtual switches that are running inside our networks. Different protocols, things like BGP, TCP, and UDP, and an alphabet soup of monitoring systems like SNMP, network monitoring agents that are running on every host, and I can go on and on. And so the complexity of the networks we operate today have increased enormously. Now, my research agenda has to do with how do we automate the management of these data center networks. And managing these data center networks is actually very hard because there's a lot of moving pieces, and when something breaks, for example, if a TCP connection is running on one of these servers has a problem, that problem can be caused by either the virtual switch on that host, any one of the switches running inside the networks and the protocols operating on them, or it could be caused by the load balancers and any of the other components that have to do with how the network operates. And there's a lot of moving parts going on, and it's impossible to get an accurate snapshot at a given point in time to know exactly what broke. And so it's almost very difficult to distinguish what's the cause of the problem and to separate it out from the effects of it in different parts of the network that we operate. Now, add to that, the security breaches can also happen. And while all of this is going on, customers are unhappy, so much so that actually when the Facebook network went down in 2014, people started to call 911. That's how upset we get nowadays when our networks break. And so this problem is not going away, and it's actually getting worse. While today we have many applications running over our networks, these applications are going to expand while we expand our reach in IoT, smart homes, and we have things like data center underwater getting deployed. And now with space networks with LEO satellites, this is even going to get worse. And our protocol stacks, which used to be nice and separated, where TCP and the transport layer was separate from the network and data link layer, this boundary is getting more fuzzy as we co-optimize these stacks and make our networks more efficient. Debugging them and figuring out what's wrong with our networks is becoming more difficult. And what we've done in the past to deal with this problem is throw more humans at the problem. And humans are notoriously bad at dealing with scale and complexity, and we make mistakes and we tend to be inefficient, and we also cost a lot of money. And when we talk about problems, if it was just fail-stop problems, maybe we would have been able to handle it. But when problems can happen due to software bugs, due to VMs getting compromised, due to configuration errors, and the most notorious of all of them, intermittent packet drops on a bad link in a huge network, becomes finding a needle in a haystack when we try to debug it. And so in my prior work, I've dealt with different aspects of this problem, and the work has been published in various different conferences. But what I would like to talk about today is what's next and where we're going. And where we're going in our research at Microsoft Research is trying to remove the need for engineers and network operators when they're doing management tasks and create networks that can effectively and efficiently manage themselves. And this requires having better visibility into what's going on in our networks, having monitoring systems that collect telemetry that we can then use in creating algorithms that would tell us what are the right configuration actions, reconfiguration actions to take on our networks? How do we approach reliability? What do we do when we're diagnosing the network? How to deal with security breaches, and how do we do capacity planning? And this requires us to adjust the resources we spend on each of these different tasks and on where we spend our monitoring resources, how do we effectively monitor, at what granularity, and all of those different questions. And so if we look at what the work we are doing today is geared towards essentially designing these different components. We have work published in HotNets 2021 that talks about part of this in terms of providing operators with the tools they need to create these algorithms. But also some of the work that's ongoing has to do with identifying the list of actions to apply when problems happen in the network, identifying the risk of each of these actions to know which one is the best one to apply at a given moment, having invariant checkers to make sure that the actions being applied and the changes being applied to the network are actually correct, and then how to allocate resources to different tasks that are going on such that there's enough capacity to operate the network as well. And then we're also looking at how to better get information from our network, how to better monitor it. Again, there's a separate paper in HotNets 2021 that talks about the early efforts in this space in terms of how do we adjust the granularity at which our monitoring systems operate, but also how do we passively monitor the networks to have an indicator of a problem before we turn on more aggressive active monitoring that actually gets us the information that we need. And with that, I'll end this talk. Again, the research is focused on how to better and effectively create networks that finally can manage themselves, and we hope that you guys will join us in this effort. Thank you.